Successive transformations, graphs. Let's apply the following two transformations to the graph of y equals 1 over x squared, having a look at the new equation each time and a sketch of the graph. Y equals 1 over x squared has the following two asymptotes. Moving the graph up by 2 units will give the following equation. So just add 2 to the previous equation, and then we need to move the graph up by 2 units, including the horizontal asymptote there. This is the graph of y equals 1 over x squared plus 2. Now we're going to move the graph to the right by 3 units. So translation in the positive x direction by 3 units. So we replace the x in the equation here with x minus 3, and we move the graph to the right by 3 units. Example 2, we're going to apply the following 3 transformations to y equals 1 over x. One over x has 2 asymptotes. After a reflection in the x-axis, we have the graph of y equals minus 1 over x. Now we're going to move the graph down by 3 units. So the new equation is y equals minus 1 over x minus 3, because we're going down by 3 units. So the graph moves down, including the horizontal asymptote, all moving down by 3 units. Next, we're going to stretch the graph using a scale factor of 2, and we're going to stretch in the y direction. So any y coordinate will be multiplied by the stretch factor of 2. So the minus 3 will become minus 6. And the new equation will be this equation multiplied by 2 to get this. So there's the minus 6. Example 3. We start off with a quadratic curve and apply the following 3 transformations. So y equals x plus 2 squared looks like this, showing the root and the y-intercept. After a reflection in the y-axis, we have the following graph. So the minus 2 here becomes plus 2, so replace the x with minus x. So you're changing the sign of any x coordinate, so the minus 2 becomes plus 2. Y coordinates remain unchanged. And then if we move the graph up by 1 unit, so a translation in the positive y direction by 1 unit, you add 1 to the previous equation, like this, and here's the new graph. X coordinates are unchanged. Y coordinates, the 4 and the 0, you add 1 to each one, so you end up with 5 and 1. And finally, we stretch the graph in the x direction using a scale factor of 2. So we're replacing x in the original equation here, in the previous one, by x over 2. So replace the x with x divided by 2. And because we're stretching by a scale factor of 2 in the x direction, any x coordinate, for example this value here, x equals 2, is multiplied by the factor of 2. So we've got 4 here. The y coordinates unchanged. Example 4, y equals x plus 2. Just a straight line, y-intercept of 2. Y equals the modulus of x plus 2. Y equals minus the modulus of x plus 2. So we have reflected the graph in the x-axis. Y equals 3 minus the modulus of x plus 2. So we're moving the graph up by 3 units. So the y coordinates here, the 0 and the minus 2, both of these increase by 3. So add 3 to these to get 3 and 1.